Welcome to our comprehensive tutorial on Apache Parquet. In today's video, we're diving deep into columnar storage and how to effectively utilize it in your Java applications. If you're looking to boost your application's performance and optimize your data storage, you're in the right place. Let's get started. First, let's understand what Apache Parquet is. Parquet is a columnar storage file format that is optimized for use with big data processing frameworks. It's designed to bring efficiency in both storage and processing, making it ideal for analytical workloads. Columnar storage means that data is stored in columns rather than rows. This provides several advantages, including better compression rates and increased query performance, especially for analytical queries where only a subset of the columns is needed. Next, let's set up our environment. We'll be using Apache Parquet with the Spark framework in a Java application. Before we dive into the code, make sure you have Apache Maven set up, as it will help us manage our dependencies efficiently. Open your favorite IDE and create a new Maven project. In the pom.xml, we need to add dependencies for Apache Parquet and Apache Spark. Here's how to do it. With our dependencies in place, let's create a simple Java class. We're going to make a class named Parquet example. In this class, we will demonstrate how to write data to a Parquet file. First, we need to define our schema. The schema describes the structure of our data, including field names and data types. For this example, let's say we want to store user data, which includes user ID, age, and name. Now that we've defined our schema, let's move on to writing some data to our Parquet file. We're going to create a few simple group instances to represent users and populate them with data. After writing some sample data to our Parquet file, let's move on to reading the Parquet file. We will use the Parquet Reader class for this. Here's how we can read the data back that we just wrote. In this read Parquet data method, we open the Parquet file for reading and iterate through each group, printing out the user ID, age, and name fields. Be sure to handle any exceptions appropriately in your code. Now let's put everything together in our main method. We will write some sample data to the Parquet file and then read it back to verify that it was written correctly. Next, let's talk about advantages of using Apache Parquet. One of the key advantages is efficient compression. Parquet files are typically smaller than their row-based counterparts, leading to lower storage costs and improved I/O performance. Another significant benefit is that columnar storage allows for better performance in analytical queries. When queries involve a limited number of columns, Parquet can skip reading the unwanted columns, which can significantly reduce the amount of I/O and processing time. Performance is also enhanced through selective reading. In scenarios with filtered queries, Parquet can take advantage of predicate pushdown, which skips reading data that does not meet the filter criteria. Now you may wonder, how does Parquet handle schema evolution? One of the powerful features is its support for evolving schemas. You can add new columns or modify existing ones without breaking older versions of your data. For instance, if you want to add an email column later, you simply modify your schema and read older Parquet files without any issues. In addition to efficient storage and performance, Apache Parquet also integrates seamlessly with various big data tools like Apache Spark, Hive, and Presto, making it a versatile choice for data storage in today's data-centric applications. Now let's explore some best practices when working with Apache Parquet. First, always use the right compression codec. Parquet supports several codecs such as Snappy, gzip, and LZO. Choosing the right codec can greatly affect your performance and storage efficiency. Next, keep your column types consistent. If you need to change a data type or the way you store your data, make sure to follow schema evolution rules to prevent any data processing issues later. Another best practice is to decide on partitioning your data dynamically based on use cases, as partitioning enhances query performance by limiting the amount of data read. Now that we've covered the essential aspects of using Apache Parquet, here's a quick recap. We've learned how to set up our project with Maven, define a schema, write data to a Parquet file, and read it back efficiently. To wrap up, I highly recommend you explore more about Apache Parquet. It's a powerful tool for optimizing data storage for analytical workloads. Experiment with different datasets and query patterns to truly understand the benefits of columnar storage. Thank you for watching. If you found this video helpful, please like and share, and don't forget to subscribe for more Java programming tutorials. See you next time.